Hi, welcome to our series on robotics with Arduino. I am Jason, and for this experiment, for our first experiment, we will be making a program that will control a DC motor using the L293D and an Uno board.
Alright, so our objectives for this experiment is to control the direction of rotation of a DC motor using H-bridge circuit, to control the speed of rotation of a DC motor using pulse width modulation, and to create an Arduino programming to control the DC motor. So, for this experiment, we will have three parts: the direction control, speed control, and direction and speed control, all of which has a schematic diagram, circuit assembly, and programming. So our materials for this experiment will be breadboard, an L293D, jumper wires, Uno board, DC motor, and a power supply. So before we proceed to the schematic diagram, let's first discuss the L293D quadruple H-bridge driver. Alright, so right here is the internal schematic of the IC. As you can see, we have internal diodes, and the motor, if bidirectional, is if we will be using the motor for the bidirectional DC motor control, the inputs of the terminals will be in the pins 3 and 6, and the motor or the microcontroller logic will be inputted to the pins 2 and 7 of the IC. Alright. So as you can see here, we have the table for the logic of this IC, where if EN is at high, the 1A and 2A as well is at low and H respectively, low and high, the function will turn right. And if it's H and L, high and low, respectively for 1 and 2, with enable retaining its high logic, it will turn left. Now, for the schematic diagram, we have here the L293D. You see the 5-volt pin of the Arduino is connected to the VCC of the L293D, and the D10 or the pulse width modulation pin of the Arduino is connected to enable 1, and the 9 connected to the input 1 of the L293D, and the D8 is connected to the input 2 of the L293D, and the external power source will be connected to the VCC2 of the L293D, as well as the ground. The ground is also connected to the Arduino microcontroller, and the motor will be connected to the pins 6 and 3 for the output 1 and output 2. Alright. So for the circuit assembly, we have here a breadboard, a power source, an Arduino Uno, and a DC motor. Now, as you can see here, the pins 1 of the L293D is connected to the 10th pin of the Arduino, which is the pulse width modulation enabled pin. And the 9th pin is connected to the pin 2 of the L293D. The pin 8 of the Arduino is connected to pin number 1, 2, 3, 4, 5, 6, 7th pin of the L293D IC. And the DC motor control, or the DC motor rather, is connected to pins 3 and 6 respectively. And as you can see here, we have two power source, one coming from the Arduino and one coming from an or an external power source, and this is for the DC motor control, or the DC motor power rather. The power supply, the external power supply is connected to the first part, the power supply pins of the breadboard, and the second one is connected to the Arduino. Now for the programming, we will show you the sped up version of the video of me creating the code for the direction control programming. Alright, so now that we have finished coding for our DC motor direction control, let me walk you through the entire program. So for the first part, we have these three macros, IN1, IN2, and cont, which are for the pins of the motor, or pins of the L293D connected to the Arduino. Now, for the IN1 and IN2, whenever these are called, it will represent a number of 8 and 9 respectively. The same goes for cont, which stands for control. It will represent the number 10, which is for the pulse width modulation. Although we will not be utilizing the pulse width modulation function of the Arduino for this part of the experiment. We will discuss that later on in the next part. But first, let's discuss this part. For the next part, we have the CCW function, CW, and stop function. For the CCW, which stands for counterclockwise, we will write the logic high for the input 1 and logic low for the input 2. Now the opposite is for the clockwise. We will write the digital output low for the input 1 and logic high for the input 2. Now for the stop, we will write logic low for both the inputs, input 1 and input 2. Now for the next part, we have here printing motor states on serial monitor. So whenever state underscore CCW is called, it will print out the motor direction counterclockwise. The same goes for clockwise. It will print out motor direction clockwise, and stop, print out motor stop. But if you will notice, we have if functions before these serial prints. So what do these do? So the CCW, CW, and stop variables are Boolean variables which are conditioned for printing states. The exclamation mark stands for not. So not CCW, not CW, and not stop is what these if functions are trying to consider. So if CCW, this means that if CCW has not been printed yet, it will print motor direction counterclockwise. And the same goes for the other similar states or similar printing functions. We will discuss those later on when we discuss the void loop, so we can understand better. So for the next part, define error. This function will do serial.println invalid argument. This is just in case we enter any character that is not in the control parameter. So variables for serial communications and conversion. Now we have these variable strcont as a string and variable cont or control for character as a character rather. So again, we have these boolean variables for the printing states. Now let's go to our setup function. So for our setup, we have pin mode IN1, IN2, and cont as our outputs. We also initialized a serial.begin, which has a 9600 baud to initialize the communication between the PC and the Arduino. We also created additional prints here for instructions of using the program, which has a character A representing clockwise and B counterclockwise, and C or space for stop. Alright, so for our void loop, we first have this digital write cont high, which will output a logic high for our control pin at pin 10. Now this is supposedly for pulse width modulation, but for this part, we will only be outputting a constant value of logic high to be able to control the speed of the to be able to see the speed of, or the direction rather, of the motor. Alright, so for the next part, if statement. So if serial.available, if this statement is true, well then it will execute the following lines. Now if this is true, it will read the string which is inputted in the serial monitor and store it into the variable strcont, which is a string variable. And it will also, now once the string is already stored into strcont, it will look for this line will look for this particular function .char at will look for the first array or the first character in that string and convert it into a character variable, which will be stored to the variable cont. Alright, so now that we have the cont, we now have the first string of the first character of the string stored at cont. We will now use cont as our conditions for the switch statements. Now, case that it is A or capital A, it will perform these functions and put these values in these variables. So for the first one, CCW function, which we have already explained earlier, digital writes high in the terminal or the IN input 1 and logic low for the input 2. And state the dash or underscore CCW will perform this function, printing motor direction counterclockwise. So these Boolean variables only represent the statement or the states that we are in. So since we are in the counterclockwise state, the CW will be equal to stop and both will be equal to false. This will help the state underscore CCW function to recognize if CCW has already been printed. It will put a value of true for the CCW. So since it is true and it's not false anymore, well then it will not print the motor direction control counterclockwise anymore unless it is called again after another instruction has been called. Later we will be you will understand that more later when we try to execute the program to the microcontroller. So the same goes for the other parts in the switch statement. Case B, that will be for clockwise. In case C or space, that will be for the stop. Now we have here default, the default of the switch statement. Now the default will have this function. So what this function does is that if the control character is greater than or equal to D, and the control character is less than or equal to Z, or the capital versions of them are met. So if these conditions are met, it will print out an error because D to Z are not in our control parameters. We only have A, B, and C. So this will print out an error invalid argument. So now that we have discussed that, let's now try uploading and using our serial monitor. Alright. Alright, so now that we have uploaded the program, let's now open the serial monitor. And as you can see, it printed the instructions: A for clockwise, B counterclockwise, C or space for stop. Please enter any of the given control parameters. Now let's first enter a control or character that is not the control parameter. So as you can see, it says invalid argument. That is because we entered P, the serial monitor. So if we entered U, which is also not in the control parameter, it will still print out invalid argument. So now let's try printing ones that are in our control parameters. A. As you can see, our motor started running. Alright. So if we try to print or type B, the motor direction changes to clockwise. And if we try to again use B or print B, as you can see, it does not print anymore the clockwise motor direction because it's already the most recent instruction that we gave. So if we press the A, it will go in a different direction, counterclockwise. And if we press A again and again, it will not print out the same instruction that we just gave it if it's already been met. Alright, so if we press space, it prints out motor stop and the motor stops, as you can see. Let's do that again, but let's now try to input C. Again, the motor stop. So let's see the close-up. I will now input A. As you can see, the motor direction runs counterclockwise. And if we change directions, as you can see, it changes directions. Now, if you will also notice, the motor runs faster in other directions. Let's say on counterclockwise direction, it runs faster compared to the clockwise direction. This is because for other DC motors, the forward runs, or the other direction runs faster than the other direction received. Alright, so now that we have finished this part of the experiment, we can now proceed to the next part, which is the DC motor speed control. And there we will be utilizing the function of the Arduino, which is the pulse width modulation.
for controlling the speed of the DC motor. Alright?
Alright, now, so for the speed control schematic diagram, right here we have the similar schematic diagram as the direction control. There's nothing that really changed from the schematic diagram, as well as the circuit assembly. Nothing has changed. And again, for the programming, we will be looking at the sped up version and as well as the demonstration of the working program.
Alright, so now that we have finished coding for our DC motor speed control, let me now walk you through the entire program. So again, we have these three macros, IN1, IN2, and cont for the pins 8, 9, and 10 respectively of the Arduino, just like a while ago in our direction control. But for this part of the experiment, we will be utilizing the pin 10 or the cont for the pulse width modulation in controlling the speed of the DC motor. Alright, so for the next parts of the motor or the macros functions, we have the motor function, which basically just starts the motor running regardless of the direction, but in this case, it's IN1 at logic high and IN2 at logic low. So define error. So this function error is just like a while ago, that if ever we entered any number that is not in our control parameter, let's say greater than 255, it will print out an invalid argument. Alright, so for the next one, we have these variables for serial communication and conversion. We have strcont again as a string, and if a while ago we had the cont variable as our character data type for the case statements of A, B, and C or space, now we have the speed as an integer value for controlling the speed of the motor. Now, as you can see, we have here uint8 underscore t. So what is uint8 exactly? uint8 stands for unsigned 8-bit integer. So this means that it only stores values that are 1 byte worth of storage, or 1 byte as a limit of 1 byte. So it stores exactly 0 to 255 integers, and that is because we have 8 bits which can store 256 integers, considering the 0 now that is a range of 0 to 255. Alright, so for the next part, we have setup, pin mode, again IN1, IN2, and cont for output. Serial.begin initializes serial communication between the PC and Arduino. We have here serial print. For the speed, please enter a number between 0 to 255 for motor speed. This is because the PWM only accepts values between 0 to 255. Okay, so for the loop, we have here the first line motor function, which starts to run the motor, or at least puts the logic for running the direction of the motor. But regardless of the direction, we will only control the speed. Alright, so the next thing that it will execute is this if statement. So if the serial.available is true, if there's any input to the serial, it will execute the following. It will read first the string that has been inputted and store it into the strcont string variable. And the next part is if the strcont int is greater than 255, it will print out an error. So we encountered an toInt function. So toInt is, what this does is it converts a string, if it's an integer, it converts a string into an integer for our function. So we did this to satisfy this condition, or at least give it some valid syntax. So what is this toInt? ToInt, as you can see, if buffer return so if buffer, if this is if this function is met, or if this is satisfied, well then it will return this part of the program. If it's not an integer, it will only return 0. Alright. So now we go to else. So considering that the strcont.int is less than or equal to 255, we will go here else, and what this does is it will store that that character converted into integer. It will store that into the speed variable, and right here we have serial, and after that it will output the speed, or let's say the equivalent speed of that integer into the cont, which is the pulse width modulation pin of the Arduino. And after that, it will print out this input number and speed, which is our inputted number into serial. And this motor speed, it will print out this motor speed in terms of percentage. As you can see here, we have converted the variable speed, which has a range of 0 to 255, into a range of 0 to 100. It will now print out the motor speed in terms of percentage. So for you to be able to understand that better, let's upload this to our Arduino. Alright. Alright, and start our serial communications. As you can see, now it prints for speed. Please enter a number between 0 to 255 for motors. Alright, so let's try inputting, let's say 900, which is greater than 250. As you can see, it outputs invalid argument. Again for 100. And again, it outputs invalid argument. Now if we try 100, it runs. The motor starts to run, and the motor speed indicated is at 39%. So let's try 10. The motor speed goes down to 3%. Let's try 20. The motor speed goes up to 7%, 11%, 15%, 19%, 60%, 27%, 90. Now 39%. Alright, so let's try and enter 255, which should be the maximum. Now the motor speed is at 100%. Let's try to slow that down to 200, which is at 78%. Alright. So as you can see, the program is working properly. We can now proceed to the next part of our experiment, where we will be controlling both the speed and the direction of the motor. Alright.
Now for the direction and speed control, schematic diagram is still the same. We will be still using the schematic diagram that we used for the direction and speed schematic diagram, as well as for the circuit assembly. Alright. So for the programming and demonstration,
Alright, so now that we have finished coding for our DC motor control, both for the direction and the speed, let me now walk you through the entire program. Now this will be short since we have already tackled these topics earlier in the experiment. So again, we have these three macros, and these are for the directions. Macros for the directions and macros for printing the states as well as the error state. Other variables, as you can see, we have now this cont and speed both in our program, boolean CW, CCW, and stop for printing the states. And now we have here the setup some additional or combined print statements. So right here we have A for clockwise, B for counterclockwise, C or space for stop, which is followed by for speed, please enter a number between 0 to 255 for motor speed. Please enter any of the given control parameters. Alright, so for our loop, we have here if again serial, if any character is inputted into serial, it will execute the following. First, it will store the string into the strcont and store the first character of that string into cont, and consider that cont character as our conditions for the cases. And for the default, we have here this if statement combined with the integer greater than 255 a while ago in our speed. As you can see, we just combined those two into our program, as well as the printing of the speed. Alright, so let's now upload this to our circuit, Arduino. Alright, enabling the serial monitor. And as you can see, it prints out these statements: A for clockwise, B counterclockwise, C or space for stop, and for speed, please enter a number between 0 to 255 for motor speed. Please enter any of the given control parameters. First, let's see what it does when we enter anything that is not in our control parameter. Let's try entering H. And again, as you can see, it prints out an invalid argument. Let's now try inputting 900 greater than 255. Still invalid argument. Now let's try inputting a proper speed first, 100. Input number 100, and as we can see, the motor speed is at 39%, but it's not running because we haven't given any control parameters for the directions. Now let's try putting A. It starts running counterclockwise. And for B, it changes direction to clockwise. And if we press space, the motor stops. Now let's increase the speed to 250, which is motor speed at 98%. And input a direction, B. As you can see, the motor direction is at clockwise and it started running soon after we have entered the control parameter. Now let's see the close-up of that circuit. Now changing the direction to counterclockwise. The motor changes direction, increasing or decreasing the speed to around 150 value, which is 58% motor speed, we can see that the motor starts running noticeably slower than the previous speeds. Let's try inputting a number 50, which is motor speed at 19%. Let's try at 20, which is motor speed at 7%. And as you can see, the motor is running very slowly compared to our other inputs. So changing the direction to B or clockwise. As you can see, the motor direction changes. Alright. So that's about it for our experiment. See you on the next one.